Hi folks, let's go for this one. Transposition of formula. Some of you know this is change of subject. So it's just moving things about. So like it says here, if you have a whatever formula y equals mx plus c, some of you might recognise this. And usually that would just be to work out y if you knew mx and also the value for c. But if you wanted to work out mx or c, and I'm saying x here, sometimes you can rearrange it specifically to get x on its own, and that would be an appropriate formula. You can have variations on that, but that's maybe one that's acceptable. So let's go for it. So all we're doing is moving pieces about the page here. As it says, rearranging the formula. And in maths, we have relationships between certain things, and they are called inverses or opposites. So maybe the most common ones: add, subtract, multiply, divide, square, square root. And I think a lot of you know about sine and inverse sine. I know you call that sine to the -1, but that's fine as long as you know what you're doing with it. So, and there's many more, and I think we'll introduce another few later on. So, I'm just going to start off with the basic operations. Operations doesn't mean you're getting a hip replacement. Operations are add, subtract, basically multiply because they're stuck together, and divide because you've got a fraction. So these are 4 basic operations that we're going to deal with. So what we need to do here is isolate x because we're saying that's a subject. What's happening with x? What's next to x? So a, and it's been added. So hopefully when you take it across, you do the opposite of addition, which is subtraction. So it would be take away a. Right. Next. X is a subject, so what's happening? Well, you get d, it's been subtracted. So take it across the other side and add. There you go. What we've got here is a stuck to x, and you know when something's stuck, it's going to be multiplying. So the opposite of multiply when you take it to the other side is divide. And we just put it, we make a fraction, that's what that is, top divide the bottom. So it's going to be b over a, and finally, you can see here the f, with f, or whatever it is on the bottom, it's dividing. So when something's dividing, it goes up to multiply. And you either put it to the front or back. And I say that in the wrong order, but it doesn't matter. That doesn't matter because it's commutative. So with either f times g or g times f, stick them next to each other. That's fine. So that's the 4 kind of basic operations. So we're going to deal with other operations. We're going to do the 2 of these in one go. So you get a square root of x. So how do you undo a square root? Okay, and how do you undo a square? Well, actually, these are opposites of inverses of each other, and that's what we're going to do with both of them. So square root of x equals z, so x is just going to be z squared, x squared equals y, x is just going to be square root of y. And I think I'm just going to leave it there. I'm sure you can cope with that. If not, then cover up either the left hand side of the page or the right hand side of the page, and vice versa. Let's move on. This is what I started with. Let's make x the subject. Y equals mx plus c. Maybe some of you recognise that. Maybe it could be the equation of a straight line. Doesn't matter. We don't know the context here, but we want to make x a subject. So sometimes people turn it around. It's not necessary. But we want to isolate x. Okay. So we need to get rid of m and we need to get rid of c. Which one goes first? Right. There's a way of thinking about this. Anything that's tightly bound to x, either multiplying or dividing, we're going to keep that. Anything that's adding or subtracting, we can get rid of that. So that there, that's going to go first. Okay. I bet I've spoke about atoms, neutrons, protons, and electrons. Like the C is like an electron or positron we can get rid of. So the C is going to go first. It's been added, so we'll take it across and subtract. Okay. Now the m is multiplying x. Let's take it over and divide. And don't put a divide sign at the end. Just put a fraction bar. And then just slip m underneath it there. So that's what we're going to do here. And then, like it's saying, move m. And that's our final answer. Okay. Let's make x the subject. Right. There's two things going on here. X squared has been multiplied by a. And I said earlier, we need to keep bundles of x. Or I said in the classroom, this is a bundle of x squared, that's x times x. And what's happened to the bundles of x? It's been multiplied by a. So a has to go first. That's what's happening here. A has got to go first. So let's get rid of a. It's multiplying, take over and divide, and to unsquare something, we square root it. We just take it over the other side, put the big square root sign over the fraction. Some people might want to bracket the fraction. You might see that in an answer. That's fine. Either or. As long as you know you're square rooting the entire fraction. Right. Okay. This one here, let's make x the subject. So anything that's tightly bound to x, we're going to keep. That means we're going to get rid of that there. It's going to go across the other side, and hopefully you know we're going to add it because it's been subtracted there. That's exactly what we've done there. And e, it's dividing there, so it's going to come up and multiply. And because you get more than one thing here, I think I'm going to bracket that. And you can put e at the front or e at the back. It doesn't matter. One little iota, one little bit. So, like I said, I'm going to bracket the f plus d, whatever's on the right hand side. I've just stuck e at the front. And there's no need to multiply out that bracket. The aim of the game is to get x on its own, and you've done that. Moving swiftly on. Oh, problem. X is on the bottom. Okay. So, there's a little trick here. If x is in the bottom, you can just swap that with whatever's on the other side. Swap it completely. You saw that in class, and you saw me do it, putting in an intermediary line. just go for that. That is fine. Just go for the straight swap. Please take that on board. Don't touch whatever's in the top of the fraction. Leave it. It's got nothing to do with x, the subject matter. Right. Okay. You all seen this part here. So this looks quite complicated. So you get 2 pi times the square root of x all divided by g. So we want to hit a target, which is x. So identify where x is. Identify what is affecting x immediately. It's not the square root, because the square root is dividing both x and g. So it's g, it's affecting x directly. Now you can move out. And because x and g are in a bundle, they are all being square rooted. So I'm moving out in layers here. And next to that last bundle, you've got pi times 2, and 2 times pi is just a number, 6 and a bit. So let's just consider that to be the one thing. So what happens here, I've given you layers here. And what we're going to do is come from the outside and go inwards in order to release x. That's what we're going to do here. So, yes, I know it's sad, unwrap the present. If you were attending class, you will have seen that. So, we're just removing the layers. So take that beautiful ribbon. Take the ribbon from my hair and get rid of it. So the outer layer goes, and what I'm not interested in having an equation here. It's just when you remove the layers, something disappears. So that outer layer, the kind of pinky shade, looks like an ice cream variety. So when I remove that, the 2 pi is going to go gone. And what you can see on the right here, on the other side, the 2 pi will go from multiply to divide on the other side. Right, we now have the green limey wrapping. Let's get rid of that. When I release that, it looks like the square root's going to fall away. So square root goes to the opposite, which is the square on the other side. That's fine. Now, we're nearly there. We're nearly at x. You can see g's underneath it. So g, when it's underneath it, it's dividing. So when I get rid of the blue wrapping paper, g falls away, but it really goes to the other side. And because it was dividing, it's going to go to the other side and times. Right, there you go. X is on its own. And as we say, it's free. Right. So let's bring back the equation, and I'm going to just put in what's happening here. So going from the outer layer with 2 pi, it goes across the other side to divide, multiply to divide. That's fine. Next, we're looking at the right hand side. We're trying to get into the x part, but that square root is blocking us. We need to get rid of the square root. So square root goes to square on the other side. And then finally, we need to get rid of g. So g is multiplying. Let's take over and divide. Sorry, g is dividing. Let's take over to multiply. There you go. And that's us, folks. And I think I'm going to just change that wee page. Don't worry, this is for my benefit and my benefit only. Hi, Tommy. You should do your editing before you come on. Right, that's just, so that's the final line. And it doesn't matter that x is on this side. If you want to swap sides, that's fine. Mathematically, that's perfectly correct. So let's go and I'll see if I'll get some sudo yeah, you did see that. So I use these in the class. So what's the subject going to be? N. Oh, is N going to be subject? Do I want to make N a subject? Let's see. I don't think I want to make N a subject. I'm going to make lambda the subject. That makes it easier. Sorry, got ahead of the game there. Like I said, my editing skills are not brilliant. So there's lambda there. So what's the only thing affecting lambda? What is it? Well, you can see it's been square rooted. So you need to do the opposite. So what's the opposite of to square root something? Right? And whatever the opposite is, do it to all of the other side. So hopefully simply just to square, and don't just wrap that up, whatever's on the other side, wrap that up and just square it in that shoe. Right. Okay, let's use the same formula and we'll make n the subject. Various ways we can cope with this. If you get something in front of a fraction, usually that just comes up to multiply the top part. I think I would personally do that and then start stripping stuff away from n. But I like to get rid of the bottom part, which is L. I'm going to take it up and multiply root lambda. That's fine. And then finally, it's n I want to go into this one, so it's multiply with pi. So the pi is going to go downstairs, and that's that there. Okay, let's move up a gear. Okay, this one's okay. Looks kind of scientific. Don't know what it's about, but we want to know what the subject is. G. Big. So this one's not too bad. So if you want to swap sides, that's fine. I've done that. So let's isolate G. You can do it in two ways. I think what I've done, I think I've taken the bottom part. It's dividing. I think I've taken it up to multiply. Hopefully you agree. Yeah, I have. So I've done that there. So it's G, you try to isolate. So see the H cube, it's multiplying. So why don't we just take that downstairs to divide? I'm saying why. No, that's exactly what we're going to do. And that's us isolated G. So just a couple of steps here, and it looks like we are fine. Right, let's move on. And here we go. So you got U. Let's see. So this is a bit bigger here. And let me see. Oh, this looks pretty mathematical here. So how am I going to deal with it? But we need to know what the subject is. Mu. Okay, so mu. Mu is a subject. So where is it? It's there. So you can either remember one of the wee tricks, and the thing is, what I need to point out here is this fraction. It's multiplying the whole bracket. So please don't care about that bracket. It's got nothing because mu is external to the bracket. We don't care about that. So mu is in the bottom of a fraction is a problem. We need to, it has to be on the top or on the level with something. So we're going to move it up here, or I'm going to move it up. And hopefully you're going to move it up. So it's dividing there, move it up, it goes to multiply, done. That's fine. But it's got a partner now. It's got that big U stuck next to it. So what I've done there is just take the U downstairs, right? Because U was multiplying the next, so I've just taken it downstairs to that fraction there, so it just sits next to the 4. That is fine, folks, that's fine. Don't touch that bracket, that is you. So, we could have done this another way, because earlier I showed you about the swap scenario, the Tommy Talk tip. Because it's part of a fraction, and the fraction is multiplying the bracket doesn't take part, okay? Just ignore that. Here, u will be swapped with mu, don't touch the 4. There you go. That is your solution. Okay. Might as well stay with this one here. Since it's such a lovely formula, let's stay with it and let's make y the subject. Y is inside the bracket, so we need to deal with the bracket now. We need to break in to the bracket actually. So whatever's outside it, we need to remove that first. So just let me expand here and let's isolate the target or the subject that we need to hit. And what was it? It was y. Okay. There's y. We've identified it. So this, we're going to do things in reverse here. What has happened to y? It's been squared. So the square is the last thing you remove. Now what's happened to the y squared? Well, the stuff in the bracket, z squared, has been added to it. That's the second last thing to get removed. So basically, that's a bracket getting removed. Outside the bracket, you've got that fraction. You can deal with that in one or two ways. So let's go for it. So, there you go. I've just turned it around for you. I'm going to remove the exterior of the bracket. So the 4 mu, I can just take that and I can bring it up to multiply u, and at the same time, because g is actually multiplying the bracket, I can take it downstairs to divide. It's just like flipping the fraction. Okay, so 4 mu goes up the top and the g comes down the bottom. That's what I'm going to do there. Okay, in one go. So basically, I've flipped that fraction. Okay, so it's doing the opposite. G goes from the top to the bottom, and 4 mu goes from the bottom to the top. That's what's happening there. Now, we need to isolate y squared, so let's get rid of plus z squared. So you know what's going to happen with a plus when it goes across. You know you're going to subtract that. Exactly. And final thing, to unsquare something, you know it, to unsquare something, you're going to square root it. Right. So I think that's us done. That looks good to me. We'll leave that, I think. I think we'll leave that. Is that as there? Yep, that's a definite. Going to leave that one, and I think I'm going to introduce a new type of function. You've seen the natural exponential function before. Hopefully, y equals e to the power x. So why am I introducing pi? Because it's a very familiar constant, 3 and a bit, and e is just a wee bit less than e. So here, as we've seen, y equals e to the power x. For us, we have seen it in a certain place. E is equal to negative mu. Let's be multiplying mu to the x over x factorial, and that's to do with probability. The probability of x happening, or greater than, greater, equal, whatever. That was involved in something called a Poisson distribution. So that's where you've seen E before. But for us here, all we're interested in is a relationship between E and what's called the natural logarithm. So E is a natural exponential, ln is a natural logarithm. We don't care about x, it could be a t, could be whatever. So let's just take us through this. So e to the power x equals a. We want to get rid of e. So the inverse of e is ln, natural logarithm. So when we get rid of e on one side, we introduce ln on the other side. And that is it. Nothing else. Here, very similar. X is in the power location. It's getting multiplied by t. But there's nothing in front of, nothing to the left of e, nothing underneath e, so we can get rid of it. So when we get rid of it, dx just falls down to the ground, if you want to call it that. On the other side, just introduce ln, the natural logarithm, whatever that is. But now, to isolate x, d is multiplying it, so take it over and divide. And folks, that is us. Right, here, if it was just e to the x equals h, that'd be fine. But it's not. We get something in front of it. We'll get b. So the b part has to go first, okay? Because we can't eliminate e until we get rid of b. B is multiplying. So we need to take over and divide. Now we can get rid of e. So to get rid of it, introduce the opposite of e, whatever that is. Well, you know it's ln, and it releases x on the left, introduce ln, and put that fraction in the bracket. Whenever there's more than one thing on the right hand side, when you got an ln, put it in a bracket. Oh, here we go. It's looking more complicated. Right, in this one, please note you've got h on both sides. This h and that h. This h with a wee zero, it means something like an original value of h. It would be a fixed constant throughout a problem. But then this one here lets you work out any other value of h, probably depending on time. And x will probably be a constant. That doesn't matter. But we are making x, we're sticking with x at this moment in time. X is going to be our subject. So here, I've just swapped sides and I can't get into the bracket, okay, where x is, so I need to get rid of h naught, the original value of h. Let's take it over, other side, and you know we're going to divide by it. There. That's exactly what I've done here. So it was the only thing in front of the bracket, so now I can release the bracket. I'm now going to take you on another page. So x, the subject matter, is in what I call the attic above E. What's affecting that? Well, the +1. So I need to get rid of that. So it's going to go to the other side. And opposite of addition is subtraction. That's exactly what I'm going to do here. Now E is on its own. Nothing there or there. So I can eliminate it. Introduce ln on our side. And there's only one thing I need to get rid of. Is t. It's multiplying. So take it over and divide by it. Hopefully. And that's it, folks. That is us done. Right, let's go and get, I think I've got one. Let's see, an actual real equation. So, there you go. Stole it from Wikipedia. So, what's the subject going to be? Oh, it's t this time, no longer x. I'm going to make t the subject. And you can see t is up there. It's an exponent of the natural exponential. An exponent is a power. So what I'm going to do here is just change sides and start stripping things away. So the original value of n, or n naught as I call it, we're going to take that over and divide on the other side. That's fine. Then e is now on its own, doesn't have anything multiplying or dividing it. We can get rid of that from the left and introduce ln on the right. Done that. So it's t as a subject again, so it's being multiplied by negative k, so it's negative k it goes across and divides. It doesn't change sign, it changes operation. It goes from multiply, divide. It goes underneath it. That's kind of fine, that answer, but I don't like it. A lot of other people don't like it. They don't like having negative sitting on the top or the bottom, they like it coming out the front. Okay. The top is positive, the bottom's negative, so overall it's negative. So usually you'd write it like that. And for various reasons, sometimes they don't like having k down the bottom there, because we get fractions within a fraction, because of n over n naught. They like to drag that out the front and put it as 1 over k with a negative in front. So you can see variations in this. But what I would say, it would be these two. It would be the solution. I know a lot of you like to try and get away with anything. Do I have to do this? Do I have to do that? And the answer is yes. The answer is yes. So it's one of those two on the right would be the solution. Okay. That's fine to there. Right, not quite finished. One last part to this, change the subject. So let me bring on board. Might have to do a slight pause here. Right, so now, instead of exponential, we'll get the natural logarithm, ln. This is fine, so we're just going to introduce, that's the only thing in front of the subject, x. We can just get rid of that by doing the opposite. So eliminate it, and it's just e to the power. And please notice, whatever's on that side just gets pushed up into the power location as an exponent. That's the final answer. Next one, same again. ln, the subject, don't care what's on the right hand side, get rid of ln and just introduce e and push that 5r up into the attic. That's you. Next one, again, ln x, don't care what's on the right hand side, eliminate ln on the left, bring down x and just put e to the power of whatever's on the right hand side and put that in a bracket because there's quite a lot going on there. That is your solution. That is it, folks. That is it for natural logarithms. Okay, so here's a couple here. And let's see what's going on. So you get a times ln x, and then you get ln of ax. I didn't say times, I said of. Because the natural logarithm, it does stuff. Just because it's stuck to it doesn't mean it's multiplying, okay? The a upstairs is multiplying, and we'll look at that now. We can't eliminate the ln because I've got an a to the left of it. So I need to get rid of that. I need to take the a away from the left, take it over and divide. Okay, now I can get rid of the ln. Get rid of ln from the left and introduce e to the power and put that fraction upstairs in the attic in a bracket to keep it safe. And that's it, folks. That's it. Okay, other one. ln, it's an outside of everything. We can get rid of that right away and just leave the contents of the bracket. So of ax equals e to the power b. Now we can get rid of the a. A is multiplying, take it across and divide. That's you. Finito. Right. Okay. Right. This one here. Let's make x a subject. Okay, that's fine. So we're going to make it the subject. I'm going to give you a wee clue here. But I just need to do a wee pause. Okay, let's go for the biggie. Let's make x a subject. There's a lot going on here. 3 times the natural logarithm of whatever's in the bracket, all plus 2 equals 8. So I'm going to bring back the technique from earlier to isolate x. So I'm just going to forget about the 8 on the right hand side, don't care about that. That's what I care about. Where is x? It's there. What is directly affecting it? F, it's multiplying it. Okay. That is in a bracket. The only other thing in a bracket is r, it's been subtracted. Okay, that's the next thing to go. Okay, that's us dealt with the bracket. Let's move outside the bracket. Can't get into the bracket. It's being locked up by ln. Need to get rid of that next. Also, not next. Next one last. And that whole thing is being multiplied by 3. Get rid of that. And actually, the first thing to go is the outer shell that we peel away is a plus 2. Right, that is the order of operations, if you want to call it that. Just look there how we did that. Isolate X, next to it, next to that bundle, next to that bundle, next to that bundle, next to that bundle. That's how we're going to deal with it. Okay. So, if you were concentrating, let's work outside in. That plus 2, going to go across, 8 take away 2. Good. Right. Now, we need to try and bulldoze our way into the bracket. That 3 is in the way of ln. Get rid of it. 6 divided by 3. Done. Now we can remove the ln. ln on the left, get rid of it. Opposite on the right is e to the power of 2. Fine. See that bracket? There's nothing outside it. We can get rid of it. Now, fx, we want to isolate fx, a multiple of x. Get rid of r. It's been subtracted. Take it across and add. And finally, the f part, we're just going to, it's multiplying, take over and divide. And that is us. We are there. It's quite a lot going on this one. Quite a lot. So take it on board. Right, one last thing to go. And you're out of here. This is quite a long lesson, this. So I'm just going to do a little freeze. You won't notice it apart from the camera coming up. You won't notice this. I'm going to freeze this and bring on the last part. Okay, here we go. We were dealing in base. See, when they're talking about bases, it's a number to a power that you use. So if you were dealing in base 2, you would deal with 2 squared, 2 cubed, 2 to the power 4, etc. For whatever reason, maybe to do with the number of fingers people have, they deal in base 10. So 10 to the power 1, 10 to the power 2, etc. So 100, 1,000, tens of thousands, a million. That's, we like base 10. So the most common are base E and base 10, what we're going to deal with. I'm not going to delve into it. So it's just, we're dealing with change of subject, so how do we deal with it? So log to the base 10 of x, actually on your calculator, it would just say log, and I'll show you that in a moment. So if it just says log x, you assume it's log to the base 10, whatever that is. So when they show, so if you were to evaluate log 100, you would just pick the simple log key in your calculator, but it's actually log to the base 10 of 100 on the calculator. So what this actually means is, what power do you give 10 to get 100? Right, so what power do you put up there? That's what they're saying here. Can you fathom out what power? 10 to the power of what gives you 100? Oh, right. Let's see. You get keys in your calculator. Some of them look like that. You can see a log key in both. Some it says above it in the back plate 10 to the x. So some of these have 10 to a wee box. But that just is waiting for a number. That's fine. So these are actually inverses. But in your calculator it doesn't say that. Right? Your calculator's just got the log kind of key. Right? You get log, and on the back plate it's got 10 to the power of something, and it, again, it might not necessarily be an x. That's okay. So here we go. So if you see log, you want the opposite of log. Opposite of log is just 10 to the power. So get rid of log, isolate x, and put 10 to the power whatever's on the other side. And that is it. That is it. Right. Here, there's a couple of things. If you've got log in front of something, sometimes they put a bracket around it. It's fine, but we don't need it because there's nothing to the left or underneath log. let's get rid of that and introduce the opposite of log on the other side. So it's just 10 to the power. Okay, now there's something going on here next to x. It's multiplying. Just take it over and do the usual and divide. Okay, that's us. That looks good. So that's our answer. Right. Oh, let's go for the final one here. So hopefully you can see that. So I think what I'm going to do, well, I need to declare the subject. I put it in a wee bracket. N, that's the small n there. That's going to be my subject. It's in the bottom of a fraction, might be a problem. So what I've done here is I've just took the 14 from that side to divide. That's fine. Then need to deal with a log. The opposite of log is 10 to the power of. I put that fraction there, this one here, in a bracket because it's 10 to the power of. That's fine. Oh, the subject matter, n, is on the bottom. So we got a wee trick here when n is on the bottom. So everything on the other side, we can just do a straight swapsies. Okay. And please do not touch 3m. It's going to stay put there. So it's only these two things that are swapping entirely. Okay. Everything's getting swapped here. And folks, that is us. I'm going to leave you with that. Please look at your notes, and this is for your benefit, not mine. Okay? Because in class is where things are happening. So like I said, I hope you appreciate this. Maybe you don't. But anyway, I'm going to close there. Right, and this will soon be up and running whenever.